Hi everybody, welcome to March's Geomagic Tech Tips webinar. We will get started in 1 or 2 minutes. I'll just let the last couple of people join if their meetings have overrun, and we can make a start. So today I'm joined by Adam, one of our applications engineers based in the US. He's going to take you through how to accurately reverse engineer threads in Geomagic Design X, showcase some of the tools that we've got available in this reverse engineering software to enable you to reverse engineer threads accurately.
Hey everyone, so we'll run through a little bit in Design X, a little bit about the Helix tool. Just granted we can set it up pretty easily, but then there is a couple little fun tools in there to just help guide you with what you're doing, and then see results. But a lot of it will work a little bit like a CAD package minus our mesh sketching, so it shouldn't be anything too surprising for some of you. Again, you might not know there was one in there because we do kind of hide it in a menu. So let's pull up Design X here and we'll start rolling with that. So you see my screen?
Yep.
Oh, cool here. I'm gonna do this, and then let me go, and I'm just gonna pull in kind of basic screw first. So let's do this guy here. So this is a pretty simple straight up auger, okay? What I generally try to do when I set these up is, again, we need to set up on the bore and pull out an axis to do that. So this I already have set up on the planes, but we can run through a little bit of just a quick how to extract some stuff. So like when I look at something, I kind of decide like, is the outside better, is the inside better? Now this is a cast part. It is a couple inches across. I think it's like 6 inches across, something like that. I'm in millimeters now, so it looks about 6. I use this little size thing down in the corner there to just help me out sometimes. But there are of course there's measuring tools, but I'm lazy. So I want to pull out the side inside the center. So I mean, to do that, I usually use on most things, I'll use our Smart Select tool to just pull that out. So I could decide like whether I think the outside is better for that cylinder or the inside is. Granted, you can pull, everything's right on the Home tab here if you want to use that. I like going in the model and just hitting Vector and hit Find Cylinder Axis, and I can plug that in and pull that out. Again, we're going to want an accurate cylinder axis for whatever the revolve is. Whether it's the inside or the outside, depends on what you pick. Okay. I usually like to start on one of the ends here because our Helix tool is, like most Helix tools, it's a little bit based on height. So I always want to start from kind of like one side, so I can say like, what is the height of this next revolution? What is the height of the next revolution? What is the pitch? Like, where does the end stop at? So I'm not just going to put some of the CAD packages will stack it by like, what's the distance between each one, rather than just doing pitch and then overall height. We do overall height. So a lot of times what I'll do is when I set up a sketch, and we'll show you here as I do it, is I'll set up like heights for the whole thing just so I know like how wide it is. But I already pulled out a couple things through this thing on the stock coordinate system, starting at the front over here where the spline input is. So, and then what I'm going to do is just show you guys like some quick stuff to put in, where I'm going to use the right plane here. I think I'm going to draw on the bottom rather than the top, just because I don't have a whole profile here. I have one here. I'd rather have 2 whole threads because again, this is pretty short. So I'd kind of want, and I need the distance between these two so I know what the pitch is. So we're going to come in. Design X standard, we use mesh sketch for like everything here. So I'm going to come in and just grab the cross section right down the middle on the bottom, and we'll hit OK on that. It flipped just because this is my, believe it or not, that's up. So that's my Y direction. So That's just how I laid it out. I wasn't paying attention a whole lot, and I made that the top, not the front. So, and then I had my mesh here, and then we're going to come in and like sketch the two things. So the first thing, I'm probably going to do, I could put in some lines for the beginning and the end here for like trimming. So let's do that. I might as well leave these in. We're not going to use them as profiles, but I could use them as surfaces. I like to come off the origin and, we'll do something like this. This can be, construction. We're just going to put them in. I can do construction on the bottom here too. And I'm just going to fit to that one. So I want to make them all the same line. So I'm going to click on both of them, then double click. We're going to make this horizontal. I'm actually going to throw a dimension in here just so I can have an overall height. Okay, and now this is a cast part. Things are going to be a little weird. There's going to be some extra material and stuff like that. It's going to get machined off the way it came. So these numbers might be a little weird. This might also be in inches. I don't think it is though, because I'm pretty sure it's an overseas part. So, and then the profile, looks a little bit, we try on the mesh sketch, it tries to give you, it does have a nice accurate rotation, just move that point a little bit here. So I kind of like this profile, looks really clean over here. You can see the texture on the part from the way it was manufactured. And then what I'm going to do is just draw in some of this stuff here. So I'm going to, you'll notice I got my, my mesh, hotkeyed. So we have hotkeys for all this stuff. I tell those people all this time, because not everybody realizes that this is Control 1. You can make it anything. You can map it to a mouse key and stuff like that too. So it makes your life a lot easier when you do that. So you'll see me just clicking my mouse button to toggle all these things. And I'm just going to highlight these in. They do look like nice clean arcs here. So we're going to do that. I'm not going to worry about the fillets down in the bottom. Again, we're just going to draw this profile in. So as far as the line, this is like watching paint dry to all of you that model all day. So even a guy's probably bored. So
we learn new things every day.
Let's trim. Those aren't going to trim because I gotta extend these a little bit here. I gotta figure out what I want to do with this radius. It's kind of just a bottom radius here, but we're gonna do this. I'm gonna push that in. Let's see if they trim nice. I like to try to use the trim to get the intersection point, but if not, we'll just do this. No, you drag you there, and we'll fit this. Again, we don't have to be like crazy because it is a cast surface. It's kind of, you'll notice I can just drag this around, snap wherever my cursor is. So I can really decide kind of what the arc should look like. If I want to try to make them tangent, I can, but there is a divot in the surface, so I don't think they're really tangent. But, and let's trim these guys here. We can always move that. We'll do our little resize, because I always forget to resize things and then it doesn't work out for me. And I'm actually going to do a fit curve here just to measure to. So I'm just going to come back into like 3-point arc, and I think we're just going to use the top of this section and do the same thing here. I just need this top corner because I need my distance for the pitch. So this is an easy way to lay this out. Nothing too fancy. It's a pretty interesting shape on this auger here. I don't know what it's for. I guess it was for conveying or something, but I'm going to pull these out into my part because eventually, we'll do, we do a solid merge to the cylinder on the inside. And we're just going to do something like this and go back in and power trim some of this stuff. I didn't put my disjointed ends on. I should probably do that before I forget to trim something that I want trimmed. And I'm going to, power that stuff. That wasn't cornered. See, you catch it right away. We'll do that. Do that. We'll do this. and I'm going to use that virtual intersection point here as my pitch distance here. So I'm fitting the same line, they're collinear, so I don't have to worry about that. I'm going to throw in my dimension here, just point to point, to figure out what my pitch length should be. So, and from there, that's really all we need. So we got the profile, I got a start point here, I can start from here, I got what my pitch distance is, and everything's at the right height already because we drew the stretch right on the mesh. So I don't have to guess about that. I don't have to guess whether any of this is going to fit. If I wanted to adjust anything into Sketch, like obviously I can come in and do that, or use Accuracy Analyzer. Like while I'm in here, if I thought anything was kind of grossly displaced, I could readjust, but it's all pretty tight. So if I was doing, like, I don't know if there was, it's like I said, it's a cast part. I don't know if there's like really any great way to do engineering intent on this, like the outer diameter. I'm sure, like, you know, we could look at something off the center line here. But again, like, you know, everything is probably cutback numbers. So somebody probably added, you know, a certain amount all over this thing just for the casting size. So this stuff's kind of a little random. I mean, we could adjust, but if it was a machine part, I think I would, but other than that, I think we're good to go. So as far as start and end point of this, again, we could do the same thing off the front face. You know, we could look at kind of what, you know, our pitch spacing is or whatever from the teeth, but they all seem a little random. Maybe the front edge isn't, but, you know, it seems like there's just a little bit of meat everywhere. So now that we can pull that out, I'm going to put my mesh back on here, and then we're going to pick our start and end points. So we'll come into, you know, like I said, we hide helix, we don't stick it on here, and it's not in like 3D Sketch. Some people use it all the time will add it into the toolbars. It's easy to configure these things, but I don't use it a ton. So I'm just going to come into insert, and then we have modeling feature, and this is where you're going to find helix and spiral. So let's go and hit helix here. We're going to grab our axis. Now I deleted my axis, so I could use a sketch axis on that. I really like to use 3D axes just based on the home coordinate systems for all the stuff the way I lined it up. So I'm going to put in this vector first, and now we're going to come back in here. Rookie mistake, forget the axis. So let me grab that. We're going to grab our start point. Okay, I have that as our start point. We're going that direction. We can see that we are going counterclockwise, which is based on, it's always based on the point direction. So if you look at that, but anyway, I could tell that this thing is going the opposite direction. So I'm gonna like flip that. Our radius is already set. So, and then our endpoint, you know, it's just arbitrary, set at like 15 here. We need to come like at the end anyway, so it doesn't really matter. And then we just need to put our pitch in and like our 2 revolutions and stuff like that though. But one of the cool things about Design X that I really want to show you is like as soon as I start out, the first thing I do is hit this plot mesh section as guide, because you can see right now what it did is it actually got that profile of the section and stuck it here. So as I drag this thing out, as I put my revolutions in there, I can actually see where the nodes are and make sure that everything is fitting. So, and it's kind of fun as I come in here and do this. I can put my pitch in of what it's supposed to be. I'll just like paste that. I think I got it, copied it. Did I copy it? I didn't copy it. Let's copy it from the sketch because I'm lazy. I know, more clicks, more clicks. Let's copy that. There we go. Exit sketch, back to the tool. We don't, we like to do this stuff live here, guys. So no, no smoke and mirrors with Design X, okay? So I'm gonna do, I would just pull it out first, and we're gonna move this so the 0 angle, of course. I'm going to put the pitch in here that I want. And then automatically it's going to give me like just how many revolutions I drug out to the end. At that point, I can just say extend in opposite direction. I want to make sure this comes around to, it's supposed to be clockwise. I was wrong. Look at that. That's what happens when it's all tight. You can't tell. I'm going to make sure this comes out like past the end, like where I would want it. This is out far enough, and I think that one's actually out far enough. So let's just do a full one here. Why not? To make sure. So again, we can see that we see a node. If we like zoom in here, we'll see the node is right at the corner where it should be for the other rotation. The other one is out past the end of the part where it should be. And like we can see that we're only extending probably like half a rotation like off the end of this part. So if you zoom in here, you can actually see like what, like this is all going to be in millimeters essentially on the grid. And the same thing for height coming off the center. So you got a 0 on your center line, you got a 0 on your start point. So you can even drag things around like by the grid here. I'm going to show you some cool stuff about this. I'm going to lock this one in first. We're going to do like another little one here just to kind of show you how to like mess with the helix tool. So we're going to do another one. I always figure leave the good one that I did first and then try to break it. So if you play with anything enough, you can break it. So let's do that. We'll leave that where it is. We're going to hit this again, and then we'll talk a little bit more about this. So if I come in here and, you know, pull this out again, and we're going to put like the same kind of dimensions in. So let's make that 0. We'll take the taper off. We're putting taper on it right now. Let's put the pitch in first just so we can see what it looks like. And then if we want, like if we wanted to add nodes or anything like that, or add taper to it, I can come in and grab like a start point here. So like if I needed to, you know, if this thing was on an angle, again, I could match the angle to what is on the graph here. So if there was a taper screw, I could go and like grab that. I don't have a tapered screw, not one that I can show anyway. They're all fancy medical things and they get upset when you just share their stuff. So we're gonna do that, but this is how you would do like a taper. If I wanted to add like another point in here, like post taper, like I could do that. So you could go and add that in. And then if we wanted to do some like variable stuff, okay, then we can really go to town because I can add new points like all over the place. So like we can drag this, you know, to whatever that one was, you know, at the same angle. I can add like another point here, then we can like taper, okay, we can change pitch in between all of them. And literally it's tracing over a graph. So there's no real way you can really mess it up. You're going by, now this is measured data, you know, as you do stuff. So if you are going to do engineering intent and everything else, you're going to round numbers and things like that to like what's there. You know, this height, you know, we could always adjust. You can click in all these to quick and adjust them, so I don't have to just drag it around. So if we came in here and said like, you know, 68, you know, we can just watch everything move over. So you can poke at stuff to see what it is you want to do. So height drives a lot of things in here just because it is reverse engineering. So we drive a lot from the height and then adjust pitch and revolution from there. So, but that's kind of how, you know, the helix tool works. I mean, it's pretty simple. If we want to add nodes in the middle, we can just get them, and you can do all kinds of fun stuff to like drag this thing around. If I want to get rid of a node or something like that, I could come in and like highlight and delete. I could also back push and just be like, oh yeah, I messed all that up. Like I want to start again. So I can just push them back and it just deletes them out. So super easy to adjust, super user intuitive. You know, if I want to throw it in the middle and do something silly, you know, you just kind of pick what you want to do. A lot of times I'll specify an overall length on something and then poke around and then go back through if there's like, you know, like some of the pedicle screws and stuff like that. They have like, you know, nifty bulges in the middle and stuff like that, and they're variable pitches as they go along. So we're going to leave this go. We're going to like cancel that one. We're going to use our stock curve here. So same thing, just like in CAD. I don't have a solid body yet. We're just dealing with dealing with this. So I'm going to come in and do a solid sweep, just like I would in CAD. I'll grab my profile here. I'll grab my sweep path. It gives me a little preview. In the sweep, standard sweep command has like all of your normal stuff in here. I'm just going to do follow path. Okay, I can do like a direction vector alignment if I want to. We can put in guide curves if it was something really complex, and we needed multiple guide curves. And then other than that, we're just going to hit go. While I'm actually in here, believe it or not, while I'm in the sweep, this is just like one thing to check, like if your path was wonky. In any of the features, you can always come in and hit accuracy analyzer. So I'm used to doing this like all the time, but if I needed a guide curve or there was something wonky with the path, like I'd see stuff shift all over. We see the red on the ends because we didn't trim them yet, obviously. This is a cast part, so there is like some lumps in it. And we're at like 0.1 millimeter now, just like 4th thou, which I think is pretty good for a part this size that's been like sand cast. So, we do see a little bit of taper. Maybe this angle's a little wrong, but then I see a lot of green in the same profile other places with like 0 deviation. So I'd say that it could be warp or something like that too. So, but now that we checked that, we're okay with it. We have our solid body out here. Okay, I can like hide our helix curve. We'll turn some of that off. We'll clean this up. As far as, trimming, did I put in? So I did put in from our sketch one here. I don't remember if I did that or not. So let's just look at our right plane. I just do like simple cuts when I do this stuff for ends. This is a pretty straightforward part for trimming. So I'll just come in and do like, rather than a mesh sketch, I don't really need the mesh portion. So I'll just hit regular sketch. And just like in any other CAD package, I'll come in and like convert that. Okay, I just drew them off of one end. So I can just resize these to make them bigger than my part. You guys already see where I'm going here, I'm sure. And we're just gonna come in the model and extrude some surfaces. Mid-plane, I don't know if people, I don't know, I use surfaces a good amount, so. And yes, I could just cut that with the sketch, but I don't know that certain CAD packages don't like that. So I got out of that habit. We let you just trim, like if I grab those sketch entities, it would just let me trim with those sketch entities instead of having to make the surfaces. But old school, make the surfaces, then cut them. So. And then, of course, we'll hide our sketches here and put my mesh back on. We can check our end cuts with the accuracy analyzer again. So, and then we just have some filleting and some other things to put back in. But other than that, like we kind of got a nice clean swept profile with the helix tool. So that's like helix tool in general. I don't know how we're doing on time here, but Guy, are you watching the clock?
I am. We've still got some time. I don't know if you want to. I got
another, if we want to talk about some stuff, we could do that. I have another little variable part if we want to look at that. So it's kind of all the same. It's just a little different to lay out. When I do variable stuff, actually, I don't really need that. I could kind of show a little bit of that one if we want.
Sure.
Let's do, do I have it on that one or do I have it? I poked around at a couple of these, so let's see what I actually have here. So on the variables, in this one, you could see like it's kind of a weird spacing. It's not continuous. I don't know if that was design intent. I don't think it was. So this is actually for a conveyor. So I think someone just drew, when we look at our sketch here, someone just drew everything basically on the 1/8 inch. Okay, it went from like 1/8 inch increases to like 1/4 inch increases, and it's just kind of a harsh transition. That may have just been an artifact of the CAD program that they were using. That they were like, hey, we'll specify each segment rather than start and ending and then let it blend. So, because there's a couple different ways we would do that in here. In Design X, usually what I would do is I would find my initial pitch here, okay? Based on that, we would do a variable helix with my initial pitch, and then I would put in my final pitch, and then I would just let this be a smooth transition. So it's not going to exactly line up with this because this is like different spacing. So, but in the middle here, you get kind of, if you are accelerating something on a conveyor, like when you just switch from doing 1/8 inch jumps to 1/4 inch jumps, like you end up with kind of a harsh acceleration, I would say. So, but again, that may have just been the way they modeled it. So I drew all these circles. This isn't going to sweep because they all intersect. Look at, because I didn't do arcs. I was just trying to figure out what the spacing was on this one that I pulled out of our bargain parts bin here that someone scanned. But yeah, it's kind of how we do that. And then I have like one more fun thing here that I could show you. That this is a little preview. Okay, we're not going to talk about this one. We are going to. I'm just going to grab this because this is like what we do when stuff gets a little bit more hairy. Okay, so I'm going to hide this guy. This is actually one of our European guys here did this way just because we were playing with the same part and I was like complaining about something, and then he's like, I love doing unroll, and I never thought of using unroll, which is a whole nother feature in here, which is we're not going to talk about unroll. Okay, what we do is we can actually unroll the mesh. Okay, this is a very cool thing Design X does. So I'm going to turn off this helix here. I can actually come in and flatten that. Okay, and then if you guys want to see where we're going here, what I'll do is we can copy. Okay, we can paste them all next to each other. And then what we can do is stuff like this. This is what we use for using like circular cams and like shift drums and all kinds of fun stuff like this. But at this point, you know, as this is a radius, okay, if this was a straight line, you'd know it's a linear, it's a non-variable helix. So it's just a straight screw. So as this turns into an arc, you get a radius. If it was like a weird couple radiuses or a spline, then you know there could be like some function to it or something like that as it's conveying. So this is just a quick way to figure this out with some math here and get your like in and out pitch. If you start your start height on one end and the end height on the other end, and you look at your pitches coming off at those two heights, then you know what your start and end pitch is. You feed that back into, you know, we can feed that back into the helix tool, okay? At that point, with our start and end pitches, I'm not going to specify every point, okay? We'll turn the sketch off here. And you'll notice if I come in and just look normal too, you'll see we're hitting like, you know, every single one, but we have a nice smooth transition now. So we're not quite exactly where all the centers are, but we have a nice smooth blend, and our start and end is the exact speed that it needs to be, which is the important part, especially conveying. You want to go from one speed to another speed based on the RPM. So, but yeah, this was I'd never really thought of unrolling it for doing a helix. I've only ever done that for like cams and stuff. So, but that was a really fun way to do it. So look up our unroll tool, very powerful. So we use that for a lot of stuff. But anyway, so that is that's the helix in a nutshell. So if we want, we can grab some questions here. If anybody has any questions we want to answer.
It was really good to see how we can utilize different functions and apply them to the same use case depending on the part that you're using. Sometimes it can be difficult to use the actual tool that has been built for that part. So being able to apply other tools that we've got in Design X to do that is really good to see. If you've got any questions, then feel free to drop them in the chat. If there's anyone that you think would benefit from seeing this, then you'll all receive the recording afterwards, and we'll be posting this to YouTube and LinkedIn. So watch out for that if you want to review. If you want to see kind of more on the Unwrap tool, then we're more than happy to take requests and put together a webinar like this in the future on that tool. It looks like we've got a question in here. When is it more appropriate to use the helix tool to cut away the material between threads versus using it to add the threads themselves, like you showed?
It doesn't really matter. I just thought that was an easier profile to draw. So there's really no, whether they go on or they go off, you know, whether you're cutting in or cutting out, it doesn't really matter. That one you could do either. I mean, it's just, I could have drew the inside. The inside was just straight barrel. So, you know, we could have drew the cuts on that and trimmed it out of a solid barrel instead of adding it on. But I just, I didn't have any solids yet, so I didn't have a way to do a cut. So I just made it a positive. But most of like like a wood screw and some of all that stuff, you know, you'd all be doing like positives on that, on like an Acme screw or something like that. Like this is like, yeah, you probably would cut them out most of the time.
I guess it would depend on the part and how it's been manufactured. If you're cutting out those grooves with a tool that is not accurate compared to the casting, for example, then you may want to use one over the other.
But yeah, just a modeling preference. So, but like I was saying, let us know what you guys, you know, like your feedback would help us put together these tech tip things, like what you guys want to say. We're all like, what do people want to see? We don't really, you know, we don't always know what questions you have. So if you have specific workflows you want to see things on or different features.
We've got another one here. Does the helix live transfer?
The helix will live transfer, yes. So, but yep, because it'll just export that spline directly to SolidWorks and use it as the same, or Inventor or whatever you want to live transfer to. Same swept path. So I haven't had really. I don't think I've had any issues with the helix tool transferring. Trying to think of a scenario where I did something silly and it might not have, but I don't think I have one.
Perfect. Any more questions? If not, then we're just over the 30-minute mark. So nice work, Adam, from Shane. Thank you, Shane. We'll give you the last 15 minutes back. Hope you found it interesting. As Adam said, if you've got any requests or if there's anything that you'd like us to deep dive into in these webinars, or even kind of shorter video formats, then let us know. Reach out to us on LinkedIn or comment on YouTube. We keep an eye on all of those, so it's great to be able to provide you with the content that you want to help you utilize the software to as much of it to the biggest capability that you can.
Yeah, and the main thing with that helix tool, I mean, people look at augers. I mean, they see stuff laying around all the time that they might get in as RE jobs, and you know, augers and screws are very intimidating. Like even from the conveying market, like bulk conveying for like powders and foodstuffs, and like even farm equipment, things like that. You look at one and you're like, man, this is a nightmare when I think about it. And a lot of them are variable pitches and stuff, or they get, you know, like on a farm equipment, they'll start out very coarse and they get slower as they go to the middle, or a higher pitch or a lower pitch as they go to the middle, stuff like that. It looks very intimidating when you throw it in Design X. You can literally put the points right on it on the graph, and you're guaranteed not to mess it up. So there's you can always check yourself, and there's the guidance right there. So it makes it kind of foolproof. You don't really have to think about it a whole lot. So super convenient.
It looks like we've got a request to look at that unwrap tool in a little bit more detail. So we can definitely put together a video or schedule another one of these webinars where we go more in depth into how you can use that and the benefits of it.
Yep, and let us know what kind of stuff you'd want to see on the unroll, because it's used for all kinds of different stuff. So if you have a specific application you're thinking about, let us know.
Even parts, if you have parts that you are wanting to see these specific workflows on, or similar parts, I know that they may be kind of sensitive information for some customers, but we can definitely look to find similar parts to showcase that tool.
Definitely. I know you guys with scanners,
right.
I mean, rather than using stuff from, you know, you might have some stuff from work, but you might have some stuff that like you could just, that's just around the shop, or, you know, parts from other things you have that's not proprietary, that might be something similar that you'd want to see a workflow on, let us know. You can scan stuff, you can reach out to us if you have specific data. So, and we, take feedback through marketing and support and all that stuff. So.
Excellent. Great. Thanks, Adam. Appreciate everyone's time, and we will see you next month.
Cheers, everyone.
Cheers.